Welcome to qnawire.
Okay, we have R1 bromo, 2 methyl butane. So what does this look like? R1 bromo, 2 methyl butane. So butane is 4 carbons. 1, 2, 3, 4. We know on carbon 1 we have a bromine. We know on carbon 2 we have a methyl. We're also told some stereochemical information. We're told that this is an R compound. Well, that's got to be talking about this 2-methyl here, because carbon 1 is not a stereocenter. It has 2 bonds to hydrogen, and you need to have 4 unique bonds on your carbon to be a stereocenter. Now, carbon 2, with its methyl group, would have a methyl group, an ethyl, and then a methyl bromo, and a hydrogen. So carbon 2 is our stereocenter, and that is what is R. So we need to determine whether this should be a wedge to methyl or a dash to methyl. Let's just assume it's a dash for now, and then we'll see if that's, we'll assume it's a wedge for now, and then we'll double check that that's correct. The reason for that is that when you put a hydrogen in the back, or the lowest priority substituent in the back, to determine this the stereo configuration, you just need to look clockwise and see if it matches in terms of priority. So the highest priority substituent here is the carbon that has a bond to a bromine versus a carbon that has a bond to a carbon and 2 hydrogens, and the lowest priority is this methyl, which has 3 bonds to hydrogen. So the priority goes 1, 2, 3, and that is clockwise, which tells us this is an R compound. Okay, so we know this is the correct starting material. And then we're told that we're going to react with sodium iodide. And when you react with sodium iodide, then you're mostly interested in the fact that you have an iodine ion. And we know it's going to go through an SN2 type reaction to displace the bromine because it's a primary carbon. And the stereochemistry on this methyl won't change. And since there's no stereochemistry on carbon 1, that's irrelevant. So our final product is the same, except for with iodo instead of bromo. And that is R1 iodo 2 methyl butane.